Doorbell transformers can indeed be directly connected to the panel box using the molded nipple. The governing standard for this type of installation is the National Electrical Code, specifically Article 725.130 in the 2020 edition. There are several key requirements that must be met to ensure compliance and safety. Firstly, the doorbell transformer itself must be specifically listed for this type of direct connection. This listing signifies that the transformer has been tested and approved for direct mounting to an electrical panel. Secondly, the transformer's installation must adhere strictly to the manufacturer's instructions. These instructions provide specific details on how to properly mount and wire the transformer to the electrical panel. Thirdly, the transformer's secondary circuit, which typically operates at a low voltage suitable for the doorbell, must be protected by a fuse or a circuit breaker. This protection is essential to prevent overcurrent conditions on the secondary side, which could damage the transformer or the doorbell circuit. Fourthly, the transformer's primary circuit, which connects to the main voltage supply, must be connected to the line side of the panel. This ensures that the transformer is properly fed with power from the main electrical supply. Fifthly, the transformer's secondary circuit, which provides the low voltage power to the doorbell, must be connected to the load side of the panel. This ensures that the doorbell circuit is properly isolated from the main voltage supply. The advantages of directly connecting a doorbell transformer to a panel box are noteworthy. Firstly, convenience is a significant benefit. Direct connection eliminates the necessity of installing the separate junction box or raceway to house the transformer. This simplifies the installation process and reduces the amount of material required. Secondly, efficiency is improved. Direct connection minimizes voltage drop, thereby enhancing the performance of the doorbell. A reduced voltage drop ensures that the doorbell receives adequate power for reliable operation. Thirdly, safety is enhanced. The direct connection provides a secure and weatherproof enclosure for the transformer. This protects the transformer from environmental factors and accidental damage. When undertaking this type of installation, it is crucial to consider several important points. It is imperative to ensure that the panel box has sufficient available space to accommodate the transformer. Additionally, the panel box must have appropriate knockouts for the primary and secondary connections of the transformer. These knockouts provide a secure and properly sized opening for the wiring connections. Now let's delve into some additional considerations. The selection of the appropriate doorbell transformer is important. Transformers are typically rated by their voltage and volt-ampere, or volt-amps, capacity. The voltage rating must match the voltage of the electrical panel and the doorbell circuit. The volt-amps rating must be sufficient to power the doorbell and any associated components. When selecting a transformer, it is advisable to choose one with a slightly higher volt-amps rating than is strictly required to provide a margin of safety and ensure reliable performance. The wiring connections must be made with appropriately sized conductors and properly rated connectors. The conductors must be suitable for the voltage and current of the circuit, and the connectors must be designed for the type of conductors being used. It is important to follow the manufacturer's instructions for making the wiring connections and to ensure that all connections are tight and secure. The overcurrent protection device, such as a fuse or circuit breaker, must be properly sized to protect the secondary circuit of the transformer. The size of the overcurrent protection device should be determined based on the volt-amps rating of the transformer and the voltage of the secondary circuit. It is important to consult the National Electrical Code and the manufacturer's instructions for guidance on selecting the appropriate overcurrent protection device. The installation of the doorbell transformer should be performed by a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform the installation safely and in accordance with the National Electrical Code and other applicable regulations. It is important to avoid attempting to install the transformer yourself if you are not qualified, as this could result in serious injury or property damage. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. It's important to understand how the NEC addresses low-voltage circuits and transformers, like those used for doorbells. The NEC aims to safeguard people and property from electrical hazards. Article 725 specifically covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Doorbell circuits typically fall under Class 2 circuits because they operate at low voltage and power levels. This classification affects the wiring methods, overcurrent protection, and other installation requirements. When connecting the doorbell transformer to the electrical panel, the primary side, which operates at line voltage such as 120 volts, must be properly connected to a circuit breaker. This breaker provides overcurrent protection for the primary side of the transformer. The size of the breaker is determined by the transformer's input current rating. The secondary side of the transformer, which operates at low voltage, such as 12 or 24 volts, also requires overcurrent protection. This is typically provided by a fuse or a circuit breaker. The size of the fuse or breaker is determined by the transformer's output current rating and the requirements of the doorbell circuit. Wiring methods for Class 2 circuits are less stringent than those for Class 1 circuits because of the low voltage and power levels. However, the wiring must still be suitable for the application and installed in a neat and workmanlike manner. The NEC specifies the types of wiring that are permitted for Class 2 circuits, such as CL2, CL2R, and CL2P cables. These cables are designed to be used in low-voltage applications and have specific fire resistance properties. When running the wiring for the doorbell circuit, it is important to avoid physical damage to the conductors. The wiring should be protected from abrasion, impact, and other hazards. If the wiring is exposed to physical damage, it should be installed in a conduit or other protective raceway. The NEC also addresses the separation of low-voltage circuits from high-voltage circuits. Low-voltage wiring should be kept separate from high-voltage wiring to prevent the possibility of voltage induction. Voltage induction can occur when a high-voltage conductor is located near a low-voltage conductor, causing the low-voltage conductor to become energized. This can create a shock hazard. The NEC specifies the minimum separation distances between low-voltage and high-voltage wiring. These distances vary depending on the voltage levels and the type of wiring. Grounding is an important safety consideration for electrical installations. The NEC requires that all electrical equipment be properly grounded to provide a path for fault current to return to the source. This helps to prevent electric shock and reduce the risk of fire. The doorbell transformer should be grounded in accordance with the NEC. The grounding conductor should be sized appropriately for the circuit and connected to a grounding electrode. The grounding electrode is typically a ground rod or a metal water pipe. The NEC also addresses the use of surge protection devices. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protection devices are installed in the electrical panel and connected to the incoming power lines. When a voltage surge occurs, the surge protection device diverts the excess voltage to ground, protecting the electrical equipment from damage. The NEC recommends the use of surge protection devices in areas that are prone to voltage surges. These areas include locations with frequent lightning strikes or unstable power grids. The inspection of electrical installations is an important part of the electrical safety process. Electrical inspections are performed by qualified electrical inspectors to ensure that the installation complies with the NEC and other applicable regulations. Electrical inspections help to identify potential hazards and ensure that the installation is safe for use. The NEC requires that all electrical installations be inspected before they are put into service. The inspection process typically involves a visual examination of the installation, as well as testing of the electrical equipment. Any deficiencies that are identified during the inspection must be corrected before the installation is approved. Now, let's explore the specific requirements outlined in NEC Article 725.130 in more detail. This section addresses the power source requirements for Class 2 and Class 3 circuits. It specifies that the power source for these circuits must be one of the following: firstly, a listed Class 2 or Class 3 transformer; secondly, a listed Class 2 or Class 3 power supply. Thirdly, a listed equipment that is marked as suitable for use as a Class 2 or Class 3 power source. When using a transformer as a power source, it must comply with the requirements of NEC Article 450, which covers transformers in general. This includes requirements for overcurrent protection, grounding, and wiring methods. The transformer must also be listed for the intended application. When using a power supply as the power source, it must comply with the requirements of NEC Article 647, which covers sensitive electronic equipment. This includes requirements for voltage regulation, noise reduction, and grounding. The power supply must also be listed for the intended application. When using equipment that is marked as suitable for use as a Class 2 or Class 3 power source, it must be installed in accordance with the manufacturer's instructions. The equipment must also be listed for the intended application. In addition to the requirements for the power source, NEC Article 725.130 also specifies the requirements for the overcurrent protection of Class 2 and Class 3 circuits. The overcurrent protection device must be sized to protect the circuit conductors from overcurrent. The size of the overcurrent protection device is determined by the ampacity of the circuit conductors. The ampacity of the circuit conductors is the maximum current that the conductors can carry without overheating. The NEC provides tables that list the ampacity of various types of conductors. The overcurrent protection device must also be listed for the intended application. Common types of overcurrent protection devices include fuses and circuit breakers. Fuses are one-time use devices that open the circuit when the current exceeds the fuse's rating. Circuit breakers are reusable devices that trip and open the circuit when the current exceeds the breaker's rating. The NEC also addresses the use of power-limited circuits. Power-limited circuits are circuits that are designed to limit the amount of power that can be delivered to the load. Power-limited circuits are often used in applications where safety is a concern, such as in children's toys and medical equipment. The NEC specifies the requirements for the wiring and overcurrent protection of power-limited circuits. The wiring for power-limited circuits must be suitable for the voltage and current of the circuit. The overcurrent protection device must be sized to protect the circuit conductors from overcurrent. The NEC also provides guidelines for the installation of low-voltage lighting systems. Low-voltage lighting systems are often used in residential and commercial applications for accent lighting, landscape lighting, and task lighting. The NEC specifies the requirements for the wiring, overcurrent protection, and grounding of low-voltage lighting systems. The wiring for low-voltage lighting systems must be suitable for the voltage and current of the circuit. The overcurrent protection device must be sized to protect the circuit conductors from overcurrent. The grounding of low-voltage lighting systems must comply with the requirements of NEC Article 250. The NEC also addresses the use of Class 2 power extenders. Class 2 power extenders are devices that are used to extend the distance that a Class 2 circuit can be run. Class 2 power extenders are often used in applications where the load is located far from the power source. The NEC specifies the requirements for the installation and wiring of Class 2 power extenders. The Class 2 power extender must be listed for the intended application. The wiring for the Class 2 power extender must be suitable for the voltage and current of the circuit. In addition to the technical requirements, the NEC also emphasizes the importance of good workmanship. Electrical installation should be performed in a neat and workmanlike manner. This means that the wiring should be properly supported, the connections should be tight and secure, and the equipment should be installed in accordance with the manufacturer's instructions. Good workmanship is essential for ensuring the safety and reliability of electrical installations. It also makes it easier to troubleshoot and maintain the installation in the future. Furthermore, understanding the specific voltage drop considerations is crucial. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for minimizing voltage drop in electrical circuits. The NEC recommends that the voltage drop in branch circuits should not exceed 3% and the voltage drop in feeders should not exceed 5%. To minimize voltage drop, it is important to use conductors that are of sufficient size. The larger the conductor, the lower the resistance and the less voltage drop. It is also important to minimize the length of the conductors. The longer the conductor, the greater the resistance and the more voltage drop. In addition to the conductor size and length, the load current also affects voltage drop. The higher the load current, the greater the voltage drop. It is important to consider the load current when selecting the conductor size. The NEC provides tables that can be used to calculate voltage drop in electrical circuit. These tables take into account the conductor size, length, load current, and other factors. When designing electrical circuits, it is important to calculate the voltage drop and ensure that it is within acceptable limits. If the voltage drop is too high, the conductor size should be increased or the length of the conductor should be reduced. Moreover, it is important to consider the environmental conditions when designing electrical installations. The environmental conditions can affect the performance and lifespan of electrical equipment. The NEC specifies the requirements for electrical equipment that is installed in different environmental conditions. For example, electrical equipment that is installed in wet locations must be listed for wet locations. Electrical equipment that is installed in hazardous locations must be listed for hazardous locations. Hazardous locations are locations where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC classifies hazardous locations into different classes and divisions depending on the type of hazard. Electrical equipment that is installed in hazardous locations must be designed and installed to prevent ignition of the flammable substances. The NEC also addresses the use of arc fault circuit interrupters or arc fault circuit interrupters. Arc fault circuit interrupters are devices that are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. Arc fault circuit interrupters are installed in electrical panels and are designed to detect arc faults and interrupt the circuit. The NEC requires the use of arc fault circuit interrupters in certain locations, such as in bedrooms and other areas where people sleep. Understanding and adhering to these comprehensive NEC guidelines, including those related to low voltage circuits, transformers, voltage drop, environmental conditions, and arc fault circuit interrupters, is essential for ensuring the safety and reliability of electrical installations, including those involving doorbell transformers directly connected to panel boxes. Furthermore, regular inspection and maintenance of electrical systems are crucial for preventing electrical hazards. Electrical systems should be inspected regularly by a qualified electrician. The inspection should include a visual examination of the wiring, connections, and equipment. The electrician should also test the operation of the circuit breakers, ground fault circuit interrupters, and arc fault circuit interrupters. Any deficiencies that are identified during the inspection should be corrected promptly. In addition to regular inspections, electrical systems should also be maintained properly. This includes keeping the wiring clean and free of debris, replacing any damaged or worn components, and ensuring that all connections are tight and secure. Proper maintenance can help to prevent electrical hazards and extend the lifespan of the electrical system. It's important to remember that electrical work can be dangerous. Only qualified electricians should perform electrical work. If you are not a qualified electrician, you should not attempt to perform electrical work yourself. Instead, you should hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC and other applicable regulations. Hiring a qualified electrician can help to prevent electrical hazards and ensure that the electrical system is installed properly. Finally, always consult the latest edition of the National Electrical Code and any applicable local codes for the most up-to-date requirements and regulations. Electrical codes are constantly evolving to reflect new technologies and safety concerns. Staying informed about the latest codes is essential for ensuring the safety and compliance of electrical installations. Remember that while this information provides a general overview, specific applications may have additional requirements or considerations. Always consult with a qualified electrician or electrical engineer for specific guidance on your project. They can assess your unique situation and provide tailored recommendations to ensure safe and compliant installation. This comprehensive approach, combining knowledge of the NEC best practices for installation and maintenance and professional expertise, will contribute to a safe and reliable electrical system for years to come.